Hello everybody and welcome back to day 11 of 30 minutes of problem solving a day. Just a full disclaimer, my throat is kind of feeling really weird today, so I won't be able to be as energetic as I usually am, but we are still going to be doing some very fun problems, okay? So, maybe I'll be energetic anyways, who knows? If we're doing math, it's epic. Okay, so we're going to start with problem 7, that's where we left off, and let's get into it, very nice. Okay, let A, B, C, D, we already read this one last time, but I will read it again because I completely forgot what it was. That satisfy the system of equations A plus B is equal to negative 3, AB plus BC plus CA is equal to negative 4, and blah blah, okay. And there exists, okay, so we basically need to find this value for them. And right off the bat, I don't see anything, because, like, you can't really factor any of them. They're, like, literally as unfactorable as they get, right? I don't know, let's see. What else? What could we even start to think about? So they're real numbers too, so they don't even have to be integers. Okay. Huh. So I guess, okay, so you got a plus b is equal to negative 3. You got ab plus, like, c times a plus b is equal to negative 4. You got, I guess we could just try to factor it and try to get the original, like, the previous one in there. So the next one's going to be abc plus d times ab plus bc plus ac, right, is equal to 14. And we get abcd is equal to 30. Nice. Alright, so what do we got? We got, what can we even do with this stuff? Bruh. What? Okay, well, let's just try plugging it in and see if that helps at all. So we get minus 3c is equal to negative 4. We get ABC minus 4D is equal to 14. And we have ABCD is equal, or 4D is equal to 30. And A plus B is equal to 3. So what can we do with that? What the heck? I don't even know what we're supposed to do with that. Bruh. Okay, what? Huh. Can we subtract and, like, factor or something? Huh, that's weird. Maybe. No, that won't really help. Well, it seems pretty close, although I'm just not. Okay, well, what happens if we did, like, okay, so we have, like, ABC is equal to 14 plus 4D, and, okay, let's just assume that D, well, okay, D can't be 0, so we could divide by D over here, so we know that ABC is also equal to 30 over D, right? Okay, I think we're onto something. I think we're almost there. Hold up. This might be, okay, well, I guess we just got a quadratic for D then. 4D squared plus 14D is equal to 30. Does that simplify now? So you get, like, 120, negative 120, and you want to get 14, plus 14. So plus 12, 10, no. Okay, so it's like 12 times 10. What other factors are there for 120? Okay, so you got, like, 1, 2, 5, 6, 8. Okay, what's the 8th one? So if you factor out a 4, 2, you get 8 and 15. That's not very useful, is it? No. What about 6? So 6, you get 6 and 20. Okay, that's what it is. So essentially we get 14D squared plus 20D minus 6D minus 30 equals 0. Factor epicness. What do we get if we factor epicness? We get, what? Wait, it's right? No, that's not right. Oh, it's 4D squared. Okay, that makes a lot more sense. So it's 4D minus 6 times D plus 5. Epic, let's go. Okay, so do we know anything about D? Whether it's positive or negative or whatever? Well, we know that, like, ABC minus 4D is equal to 14. That doesn't really help at all. Does it help? Not really. Yeah, that doesn't really help at all. Okay, so we know it's one of these two. That we could just try both and see what happens. Well, okay, what do we have before? So we had ABC is equal to 30 over D, right? And ABC is equal to 14 plus 40, right? So either of these work, but what do we want to do? Okay, so what else we got? We got AB minus 3C is equal to negative 4. Okay, so let's just say we do this. So we get AB is equal to 3C minus 4, and then we have AB is equal to 30 over over CD, right? So now, if we plug this in, we could get a quadratic for C as well. So we get 30, or no, what? Yeah, 30 is equal to 3 C squared D minus 4 CD, right? And we basically want this quadratic to be solvable for C. So why don't we try that? So 3 C squared D minus 4 CD minus 30 is equal to 0. And we could either, okay, well, should we try quadratic formulating this? I hate quadratic formula so much though. Let's see. Can we do this without quadratic formula as this question? Well, let's just try both. So we got negative 5, negative 15C squared plus 20C minus 30 is equal to 0. So 150 and 20. 15, 10, no. 30, wait, what? Wait, what? 30 and 15 doesn't work. So you have 5 times 3 times, okay, so we have 15 times, okay, so 15 squared times 2 is what we needed to multiply to, and we needed to sum to 20. How the heck do you get that to sum to 20? Is that even possible? Because then you need, okay, that's not even possible, is it? Yeah, that gives you an irrational number, which might be legal, but doubt it. Yeah, I don't think you have irrational numbers because a plus b is definitely a. Actually, I guess you could, theoretically. Huh. Alright, well, okay, let's just, okay, so you got like negative 3c squared plus 4c minus, oh, we're trying to divide by 5, right? Okay, so minus 6, 18, yeah, that's definitely not happening. So what happened if we did 6 over 4? Which is 3 over 2. So 3 over 2, we get 30 is equal to 27 over 4d minus 3 over 2, right? So 6c. Okay. Now, if we divide by 3 and multiply by 4, we get 8, or sorry, this c squared. We get divide by 3. So that's a 9. Yeah, so that's a 9. So 9c squared. Whoops, 9c squared. Bro, what? God dang it. Well, why you gotta do this to me? Alright, there we go. 9c squared, okay, minus, you see, multiply by 4, right? So, minus 8c minus 120 over, okay, so 1040, okay, equals 0. So we need like 360, and it sums to negative 8. So negative 30, okay, what? Negative 36 and 10, no. Need it closer. Negative 18 and 20, no. What? Huh. Yeah, how does that even work? You need like, so you have like 8, but you need a factor of 8 on both sides, otherwise it won't sum to a factor of 8. Huh, I guess that doesn't work then, I suppose. Actually, okay, so if we do like a 2, okay, so what do we got? We could do 4, 2, and then 9 over here, no, that doesn't work. We could do 9 over here, 36, and 10, yeah, that doesn't work either. So I guess our C does have to be an irrational number, which is not ideal. Bruh, aw, that's not nice. Come on, bruh. So ABC minus 4D is equal to 14, and AB minus 3C is equal to negative 4. That is not ideal. Okay, let's see. What else could we do? Really? Okay. Maybe. What else could we try to do? So ABC is either equal to negative 6 or ABC is equal to negative 6 or what's the other option? Plus 3 over 2 over here. What is, okay, so plus 6. Or sorry, so this is 3 over 2. That would be negative 6, and then that would be positive 20. So ABC either equals 20 or negative 6. So you either have 20 over C is equal to, oh, maybe I just did it wrong the first time, minus 4, or negative 6 over C is equal to 3C minus 4. Oh yeah, I was just doing it wrong the first time. So 3C squared minus 4C minus 20 equals 0. Okay, that should be a little better. Is it better? I don't know. How do you get factors of 60 though that are 12 and okay, 12 and 5 doesn't work. It has to be split up. So you get like 10 and 6. Oh yeah, 10 and 6 works. Okay, so this works. So let's do this. So 3c squared minus 10c plus 6c minus 20 is equal to 0. Factor it out, we get c plus 2 times 3c minus 10 is equal to 0. So we got d is equal to, which one was this for? This was for d is equal to negative, or d is equal to 3 over 2, and c is equal to negative 2 or 10 over 3. Alright, so now we're actually close. Okay, so if it's 10 over 3, then we basically have, is it positive 10 over 3? Yeah, negative 2 or positive 10 over 3. So that would be 10 over here. So that would be 6. So AB equals 6. And a plus b is equal to negative 3. Square it. Well, okay, so this is easy to find the squares, sum of squares, right? We just do 9 minus 12, right? Square this, subtract twice of that. And we get negative 3 as the sum of the squares. No, that's just not right. Okay, so I guess you can't do that. So we do c is equal to negative 2, in which case this is going to be AB is equal to negative 10, actually. Right? 2, this becomes positive 6, and yeah, negative 10. And then this becomes 9 minus negative 10, which is 19. 9 minus negative 10. Yeah, okay. So, if we add all this together, we want to add 19 squared plus 3 over 2 squared plus 10 over 3, no, plus negative 2 squared. We get 361 plus 9 over 4 plus 4. And that, okay, we're almost there. So, well, okay, this is kind of sus because this number is kind of big, which is annoying. Yeah, that's way too big, right? 3 over 2 is what we did, right? Yeah, 3 over 2. We got c is equal to negative 2. So that's negative 2, that's negative 10. And a plus b is negative 3. So you square that, you get 9, and you subtract negative 10. Oh, you have to subtract. Okay, so it's 29 over here. I mean, that's even bigger. What? Okay, hold up. What? Okay, maybe we had to try a different strategy. Sum of the okay, we only want the sum of the squares, so maybe we could be a little smarter about it. So how do we, okay, so how do we find the sum of the squares, or the square of d? So we got like, I mean, this works, right? Why would it not work? And okay, let's see, what sums to 10, what multiplies to 10? Okay, 5 and 2 literally works here, negative 5 and, okay, so let's see, let's try negative 5, okay, so negative 5, positive 2, and negative 2, 3 over 2. Let's try and see if that works. Oh, wait. Oh, this is literally the sum. You don't square it again. Oh my god. Oh, smart. Okay, 29 plus 3 over 9 over 4 plus 4. Okay, that makes a lot more sense. Let's do it. So we get 33 times 4 plus 9 over 4. That gives us 132 plus 9 is 141 over 4. And that gives us an answer of 145. Let's check that. Epic, let's go. Let's go, very nice. Okay, problem number 8. Oh, did I forgot to put my timer on. We'll just use OBS then. Okay, that works. An ant makes a sequence of moves on a cube where a move consists of walking from one vertex to an adjacent vertex along an edge of a cube. Okay, initially the ant is at a vertex of the bottom face of the cube and chooses one of 3 adjacent vertices to move as its first move. Okay, for all moves after the first move, the ant does not return to its previous vertex, but chooses to move to one of other 2 adjacent vertexes. Okay, vertices. All choices are selected at random so that each of the possible moves is equally likely. The probability that after each move, it's on the top face. Okay. So, we got this. For all moves out of okay, never returns to its previous vertex, but it chooses okay. And where does it start? Okay, so it starts somewhere at the bottom, and then it chooses to move forward. Okay, so it doesn't ever go backwards necessarily. Okay. So then we just need to count the number of paths where it actually ends up at the top. So the number of total paths for 8 times is 3, right? There's 3 ways to go from the first guy, and then 2 from there on, right? So it's 2 to the 7th. Okay. Then we basically had to count how many paths work, so that shouldn't be too bad, right? So essentially, you could stay 1, 2, 3, 4, 5. Okay, and then you want to stay. Okay, well I guess I guess that's not that easy. Okay, let's see. Um. Well, I guess we could just do probabilities after the first move. So probability after the first move is 1/3, 1/3, 1/3, right? The probability after the second move is going to be 1/3 times 1/2 over here. So 1/6, 1/6, and then 1/6 from this guy. So there's actually 1/3, 1/3. That's going to be 1/3. Oh, so all these guys are 1/3 again, right? Right? Yeah. So then they're not actually going to go back, so they could go these ways. So 1/2 goes that way, 1/2 goes that way. So essentially 3/1/6 come here, right? So this is going to be 1/2. And then, well, okay. Well, this one came from, oh, it depends on which one they come from, right? So half of this came from this one, so it'll have to be plus 1/12 over here, right? And half of it came from this one, so half of it will want to go over there. So it's 1/6 over here, right? Like from here and here, and 1/6, 1/6. And how many moves is that? So we got 1/3, 1/3, and then this is the fourth move. Or no, what? 1, 2, 3. So this is the third move, and it's already kind of complicated, okay? So let us write it out. So we essentially got 1/6 here, 1/6 here, and 1/6 there, and we have 1/2 over here. So what does that actually mean is a question, bruh. Okay, this is kind of yucky. I don't like yucky problems, god dang it. Okay, well, we could try. Well, I mean, we're kind of getting somewhere, because we know, like, this one came from these two places equally, right? So, essentially, it's going to be, like, 1/2 of these guys are going to go end up here, right? So, this is a total of 1/2, so this is going to be 1/4, and then this guy came 1/3 from each of these places, right? So, he could go either here or here with probability 1/3 or 1/6 times 1/2 to each of these. No, but then you multiply by 3, right? Because, yeah, you multiply by 3 because, or 2. Wait, what? This is confusing. Okay. Well, suddenly we had to distribute this guy out. So, yeah, it distributes equally these 3, right? It doesn't make sense because it's symmetrical. So, this is just going to be 1/6, 1/6, 1/6 from this guy. But these guys actually contribute as well. So, if this is 1/4, then these guys also have to be 1/4 over 3, so plus 1/12 too. Plus 1/12, what is that? 1/6 plus 1/12, 3 over 12. Is that right? Yeah. So that would be 1/4. Okay. So essentially we got 1/4, 1/4, 1/4 everywhere. 1/4, 1/4, 1/4. And this is after, okay, so we had 1/3, 1/3. Okay, so this is on the third move, right? So that basically means this is on the fourth move. And now, if we have all 1/4, does that actually make it easier for us? I feel like it should, right? So this guy evenly distributes to these 3, right? Because it was evenly entered by those 3, right? So this should be 1/12. Okay, 1/12, 1/12. And then these guys, they were not evenly distributed, right? They got 1/6 from here and well, yeah, 1/6 from there and one. Wait, what? No. They got. Hold up. What? No. So they got 1/12 from both of these guys combined, right? And then they got 1/3 from 1/6 from this guy, right? So they got 1/6 from this guy, which means that 1/6 get distributed equally this way, right? So you get plus 1/12 plus 1/12, right? And then you have 1/24 from this guy, so that ends up going 1/48 there. Holy dude, this is so yucky. Oh my. Yeah, because you actually had to keep track of where they came from. Okay, hold up. So let's just write this out a bit neater, right? Okay. Oh, this is getting nasty, dude. Holy. Okay, I don't think we're gonna be able to make it through two problems if they're this bashy. Okay. So if you got like 1/4, 1/4, 1/4, 1/4, then if 1/6 came from here, that distributed equally, so 1/12, right? And you get 1/12 from this guy, so 1/12 plus 1/12. Oh, we only had to do it like one for one guy, right? Okay, so this is considering like the part that comes from here to there and this coming from here. So now we need to do it like in between, right? So from this guy, like you got 1/24th, right? So um yeah, so you get 1/24th from here, and then that could go either here or here. So you get like 1/48th here and 1/48th here. Whoops. And the same thing happens from here, so you get that times 2, and this times 3. Okay. Wait, no. It's actually times 4? No, what? Yeah, so this is only, no, it could come from here too. But it won't, what? Okay, yeah, that's right. So it either comes from here or here to get here. So this all sum to the right number, so you get like 1/6, or, so you get like 1/24, so 5/24 here, right? All the corners, and 1/16 here, but that doesn't seem like it sums to 1, right? So 15/24 is 5/8. Yeah, that's not right. So 1/24 plus 4/24 gives you, yeah, so that does give you 5/24, and then you multiply by 3, that's 5/8. So this is actually times 6, because you could either come from here and then go there, or you could come from here and go there, and they're both 1/24 times 1/2. Oh, so it's times 6 here. So that would actually make it 1/8, but that's still not right. Okay. Huh. We're getting there. Okay, so this is like from here to here, right? So that's 1/12, okay? Because it's 1/4 times 1/3, okay? Oh, wait. So you got 1/12, right? So it's 1/12 times 1/2 from here, though. Okay. We need to restart. Let's see. So this 1/4 was 1/6 from these two guys, or no, 1/6 from this guy. Oh, that's what it was. Okay, yeah. So it's 1/6 from this guy, so that's why it's 1/12, right? Okay. But then you could also go 1/6 from this guy, 1/12, so that's another 1/12. And then it could also go from here, there, right? In which case it's 1/24th. Yeah, because you got 1/12 from both of these guys, so you get 1/12 from this guy, so plus 1/24th times 2, right? Because both of these guys send it. Or no. Well, yeah, you get it from this guy too. But then in the times 1/2 again, because 1/24th, and then it could either go this way or this way. So it should actually be times 1/2. But that seems a bit more right. So now it is actually 1/24th plus 4 over. Wait, same thing. Really? Oh my god. So 1/24th. Oh, this guy. We didn't count this guy yet. Oh, okay, that makes a lot more sense. So this guy is just plus 1/12 again. Okay, that makes so much more sense. So this is actually going to be 7/24, right? Okay, that's right. Alright, that took a while. Holy, how much time did that spend? 20, okay, whoa, that spent like 10 minutes, but we're almost there, right? So, this is actually the fifth move, right? So now we have 7 over 24. We need to find a formula. I'm pretty sure we're basically at the formula, but like, not quite. So this is 1/8, 7 over 24. Okay, I guess we need to like split it up into how much comes from these like corner guys, right? And then that gets equally split between this guy and these two guys. What? No, okay, so 1/2 of it goes here, and then 1/4 of it goes here, and 1/4 of it goes along this way. From what comes from these guys, okay? And then whatever comes from here gets split evenly that way. Okay, so how much came from these boys? So 1/12 came from this guy, and the remaining came from these guys. Okay, so 1/12, bruh. So 1/12, why did it keep going there? Okay, 1/12 came from the corner guy, right? And then uh, how many came from the? So 1/12 came from the corner guy. That means the remaining 5 over 24th came from the other guys. And essentially, what we did is for these guys, whoops. Okay, hold up. So for the corner guys, 1/3 goes each way, so that's easy. But in this case, 1/12 goes half half. Bruh. Hold up. So 1/4 is 1/6 and 1/12, right? So essentially what happens is we took the 1/12 that came from the other guys and we split it into fourths, right? So 1/48 went here, and it came from both sides, right? Or what? Um, well, yeah, so, oh, so 1/2 could go here. Wait. Yeah, so 1/4, we got 1/48, right? Could go here. And then we multiply that by 2. And then we add in what comes from this part, which came from the corner. And then that's just split 1/2, right? And then you add plus 1/12. No, that's not right. Bruh. Oh god, this is actually so troll. Okay, I mean, we should know a formula. I mean, I feel like there's a easy formula that I'm trolling. Let's see. 7 over 24. Okay, yeah, you know what? Let's just do it symbolically, right? So if this is like P corner, right? This is P, or P corner, P edge. It's not really an edge, but we kind of get the idea, right? And eventually, let's say P corner is always divided by 3, so this is always going to be PC over 3, right? And then we had to add in whatever comes from the edges, right? So the edges can get some amount from a corner, right? Which is like this guy, so they could get some from this guy. So they get equals like PC prime plus PE prime, right? So essentially we get some amount from the corner, right? And that gets equally distributed here. So that's just plus PC prime over 2, right? Then essentially we get we also had to keep track of which came from an edge. So this guy came here, so half of it will actually go there, half of it will come here, and then the other edge that came here is actually from this guy, right? So, and also like, okay, yeah, so, and then the other one doesn't really matter, so we had to divide by 2, PE prime over 2, right? Because essentially only this one counts, right? And also there's a 1/2 chance it goes up to the corner, so PE prime over 4. And then you gotta multiply this by 2 because there are 2 PEs coming in here, so times 2. Alright, and is that right? So we get PC over 3 plus PC prime over PC prime plus PE prime over 2. And essentially what we had is we had PC was 1/4, so 1/12, plus PC prime, which was 1/6, plus what? 1/6, right? So yeah, so plus 1/12 over 2. So plus 1 over 24, is that right? So you get 4, 5. Yes, okay, there. We finally got the. Holy, that took me a while. I'm sorry, guys, but we did it, boys. Okay, we got something. Now, essentially, we could do it a lot faster. So, our new one that came from a corner is actually just going to be over 3, right? Or how much? Okay, so how much of the new, uh, how much of the new whatever comes from a corner? So, new comes from a corner does this part, and then this is just whatever comes from an edge, right? So we had 1/2 and 1/6, right? So essentially, yeah, then we get 1/6 come from a corner. This much comes from an edge, which would be 1/4 plus, or what? Um, oh, okay. So essentially, now the next thing is actually going to be things that come from a corner. So if we have, okay, so this is 1/8, right? And then this is 7 over 24. Now we could calculate it again using 7 over 24, or 1 over 1 over 24, right? Plus PC prime. So how much came to these guys from center? It used to be 1/4, right? So now it's actually going to be 1/12. And then um, how much came from a edge? So if 1/12 came from a corner, that means that the remainder came from an edge. That's plus 5 over 24 over 2, so 5 over 48. And that gives us our corners are actually going to be um, corners are going to be what are the simplified? So this is the fourth. Oh, this is the fifth. Yeah, this is the fifth one. So this is going to be um what 5? Okay, so this is 9 over 48 plus 2 over 48 is 11 over 48. Okay, and that means that the remainder is 17. No, what? 11 over 48. Really? Wait, no. So 33. So it's going to be 15 over 48 is what's left. Does that make sense though? Um, that seems kind of not right, but uh, times 4, 9 plus 2. Yeah, okay, I guess that should be right. Then we get 1 over 24, and then we get 15 or 5 over 48 plus 1 over 24 plus PE over. So how much was PE? So this is PE. Um, that's basically going to be 9 over 96. Okay, so that becomes 19 plus 4 is 23 over 96. Okay, multiply by 3, 69 over 96. So what is the remainder? That gives you 25. Okay, 25 over 96. So okay, so it was 1/3. Then it was 1/3. Then it was again 1/3, 1/3, 1/3, and then it was 1/6. So it's like 1/2 from each of these guys, right? Yeah, then it was like 1/6, one no, sorry, 1/2, 1/6, 1/6, 1/6. So 1, 2, 3, 4 is 1/4, 5 is 7 over 24, 6 is 11 over 48, and no, 6 is, yeah, 6 is 11 over 48, 7 is 23 over 96, and now we're almost done. Hold up. Okay, so 25 over 96 is, or how much is from center? So this is from the center. So now you get like 25 over 96 times 3 plus, um, plus what do we need? We need, PC prime, which is how much? 1 over, no, what? No, it should be 23 over 96. Oh yeah, okay, so that is 1 over 24 plus 1 over 24. Wait, what? No, what? No, that should be plus 15 over 48 is what happened last time. Okay, and then plus, plus, so it was 1/3, 1/3, 1/6, 1/4. Okay, so I guess it's going to be just twice of whatever we get here. So plus the edge, which is going to be 1 over 24 plus, so that would be 13 over 96 plus 13 over 96 over 2. So 13 over 96 times 2. And then we just want to multiply this by 2. Okay. So we got to solve this. Okay, how do we do this? So we multiply this by 6, right? You got like 80, you get 80, right? So you get 105 plus, multiply this by 3, I guess. Oh, so this is like times 2 though. So 80 plus 50, 130 plus, times 3 is 39 over 96 times 3. That gives you 169 over 96 times 3. 169 is not divisible by 3, and doesn't seem like it's divisible by anything useful. So, if we just simplify this, we get 96 times 3, 8128. So 288, 169 over 288. This seems kind of hard. I don't think this is right, actually. We might have to do it next time, but let's try it. We get 71514, 457. Feel like that's not right, but we'll see. We'll see. Holy, that is disgusting. Okay, well, that is not even close, bruh. Holy, that is disgusting looking. Okay, I think we got the right idea though. You know, how much time do we spend on that? Okay, so it's like 40 minutes now, but I kind of want to solve it, bruh. Okay, let's be a little bit more careful, right? So we'll keep track of everything separately, right? So essentially, our recursion is PC plus PC prime, PC over 3 plus PC prime plus PE, right? Over 2, okay? Then it starts as 1, 1/3, 1/3, 1/3, then 1/3, 1/3, 1/3, then, these guys go, so this actually becomes 1/2, and then these are all 1/6. And now, we actually have to keep track of how many came from where. So essentially, we get 1/4, 1/4, 1/4, but we get 1/12 from the edges and 1/6 from these guys, and then this becomes 1/4. Okay, or sorry, this becomes, yeah, that's become 1/4. 1/12, 1/6. Okay. So now that we have this, our PC over 3 is 1/12, right? Our PC prime is 1/6, and our PE over 2 is 1/24. That gives us 7 over 24 and 1 over 8. So our PC is 1, or PC prime now is 1/12, and our rest is 5 over 24. And our PC is 1/8, so we get 1/24 plus 1/12, right? Or sorry, yeah, 1/12. Wait, yeah, because this is okay. So that's our. I keep flipping it. Whoops. Is that right? Yeah, that's right. Cause yeah, one. Yeah, okay. So 1/12 plus 5 over 48. This gives us. We multiply this by 4, 9. This gives us 9 plus 2 is 11 over 48, right? Okay, so 1/4 is actually going to be 4 moves. Okay, so this is 5th move. This is 7 over 24, and now this is the 6th move. Okay, this is 6th move. Then essentially we get that the remainder is 15 over 48, right? Because 33 minus 48, so 15 over 48. And our PC prime is now going to be 1 over 24. Remainder is 9 over 48, right? And then our new PC is actually going to be just 5 over 48, or 5 over 48, yeah, okay. Now we sum this, we get, yeah, I don't know what, I had to divide this by 2, so this is 96. So on our 7th move, we actually get 1/4 was actually where? 1/4, 1/4, 1, yeah, so that should be times 2, okay. Oh, maybe we had to go one more step. I thought we did go one more step. Okay, so we get this, and this is like times 2, 10 plus 4, 14 plus 9 is 23 over 96. Okay. And then times 69. I mean, you get 69 if you multiply by 3, and the remainder is what? 25, right? So you get 25 over 96. That's right. All right. Oh, is it? Yeah, it's 27. That's the problem. Oh my god, dude. That is what we did wrong. Bruh, I'm triggered. Okay, so 27 over 96. How do you simplify that? You get divide by 3. You get 9 over 32. Okay. So now you actually get 3 over 32 plus your PC prime, which is 5 over 48, plus your remainder, which is actually going to be 13 over 96 times 2. And that is that, yeah, okay. And now we should be almost done. And we multiply this whole thing by 2. So that cancels out. That becomes a 24. That becomes a 16. And now if we multiply this by 4, this by 6, so we get 20 plus 18 plus 13 over 96 gives us 38 plus 13 is 51 over 96. And divide by 3, and you get 17 over 32. Which is your answer, right? What was it? 49? Oh my god. I'm actually happy I got that. Bro, is it actually? Let's go. I just messed up that one thing. What did I put? I put 25 over 96 instead of 27. Bro, that's such a stupid mistake. Okay, when you do recursion, you gotta be very careful. Anyways, that was kind of a long one, but hopefully it's entertaining me, watching me solve this last one, but that's all I got for you guys today. Hopefully my voice wasn't too bad. It's been kind of bad today, so I brought my epic water. Oh, that feels so much better. But we are good. Okay, see you guys next time. Bro, let me turn off the stream. Okay, there you go. Bye-bye.